Hello, I am John Ronkanen. I am an undergrad TA here in first year engineering, and I primarily help out with teaching EGR215. As many of you know, we often have problems when we try to run stepper motors through Matlab because they run very slowly since Matlab is interpreted, not compiled. However, I believe I found a solution to this using the Arduino IDE to run the steppers while we use Matlab to simply tell the Arduino when to turn on. The first thing you're going to want to do is build this circuit here. So you're going to have your Arduino connected to your computer. Then you're going to run the negative sign to ground, plus sign to 5 volts. Then you're going to connect in 1 to D8, in 2 to D9, in 3 to D10, and in 4 to D11, and simply connect your stepper motor like so to the motor sheet. The next step is programming the Arduino. So this here is the Arduino IDE interface. You may not be very familiar with it, but that's okay because we primarily use Matlab. So here are a few key features. This is where you type in all of your code, similar to Matlab. Down here is where the IDE gives you a little bit of feedback, again similar to Matlab. Up here in the top left corner, you see the verify button, this little check mark. If you click that, it'll quickly run through all of your code and check it for any errors. If you click this little upload arrow, it'll actually put all the code onto your Arduino. And then you have new, open, and save, similar to Microsoft Word. So the first thing we're going to want to do is include the stepper libraries. Next, we're going to define some constants and variables. So this here is defining the number of steps per revolution in these motors. In reality, it's actually 513 steps per revolution, but for additional speed and torque, we're going to multiply that by 4 to get the number up here. Then we're going to just create this little variable for rotating. This is the line where we actually initialize the stepper itself. We're going to call it myStepper, and it's going to have the properties of number of steps per revolution equal to what we put in up here, and this is the important part. You're going to need to specify the pins in the order of 8, 10, 9, and 11. Because if you specify it as 8, 9, 10, 11 like I did, you're going to get messed up and it won't run in reverse. Everything down here in the void setup loop only runs through once. So this is where we open up the line of communication between the computer and the Arduino while the Arduino is running, and where we set the speed of the Arduino to be, the speed of the stepper to be 10 RPMs. In reality, it's actually going to be 40 RPMs since we multiplied the number of steps per revolution by 4. We're also going to multiply the speed by 4. Everything down here in this void loop is the main program. It's going to run continuously in a giant loop. So what we're going to do is first of all check and see if the serial port that we opened up here is available. Otherwise, it just skips it. If so, it's going to read in the value that is written onto the serial port, in other words, the value that's coming from the computer to the Arduino, and it's going to put it into a variable called rotate that we established earlier. Then we're simply going to tell the stepper to rotate the same distance as we read off. Again, there are 513 steps per revolution, so if you wanted to make an entire turn around, put in the number 513. Then we simply return the value of rotate to 0. That's it for the Arduino code. Now it's time to program Matlab. So we're going to do some basic initialization. We're going to delete any existing serial ports and then establish one called S on whatever port the Arduino is connected to. In my case, it's COM10, it could be COM3, COM4, whatever for you, and set it at 9600 bits per second. Now you're going to want to pause the program for 2 seconds after this because I've found that if you don't, Matlab just skips the entire next line of code. I don't know why. What's down here is what's going to be in the main body of your code whenever you want to tell the stepper motor to move. You're going to have some value, I'm just calling mine dist for distance, that you're going to get by math to figure out how far you want the stepper motor to actually rotate in number of steps. Again, 513 steps per revolution. But this is going to be an integer data type. So when you actually go to use the write function to put it on the serial port, you're going to use the int2string function here to convert it to data type string, and you're going to specify that as data type string. Now it's time to put it all together. So first thing you're going to do is come over here to the Arduino IDE and click on the upload button, the little arrow up there. You'll notice that the Arduino will flash a little bit as it uploads. Then you're going to come over to Matlab and simply click on the Run button. And Bob goes spinning. Now for a little bit of troubleshooting, let's say for instance you're in the IDE and you try clicking upload, but it gives you this error, problem uploading the board. That means that over here in Matlab you're still connected to the serial port. In fact, if you look, we do have a variable called S, and it is in fact the serial port. So all you have to do is come down here and type in clear S, and then hit enter. So you can come back to the IDE, click upload again, and it works. Also, if you find that your stepper cannot run in reverse, you need to check the order of these pins right here. Thank you, and I hope this video has been helpful.